So at the start of our weak acid strong base titration curve, the pH is going to be completely determined by the pKa reaction of our weak acid. So here we're going to start with a generic amount, 50 milliliters of 0.1 molar solution of acetic acid, and then in subsequent videos we'll be adding in our strong base to it. But right now we're starting, so we have not added in any strong base. And remember, we will be regularly using these abbreviations for acetic acid and acetate. So we do need to know the Ka in this case, and with this it's a basic equilibrium problem. The pH is going to be determined by the Ka reaction of our acetic acid. So we know we have 0.1 molar, we assume some of that's going to disassociate X to make X amount of hydronium and X amount of acetate. We can come up with our equilibrium expression, products divided by reactants here, and then we plug in these algebraic expressions into our equilibrium expression. We then assume X is small, and then we solve for X. So the X compared to 0.1 is going to be small, so that's going to disappear, and we combine these two X's together to make X squared. And then we multiply both sides times 0.1 to isolate X. So this is our Ka right here. We multiply both sides by 0.1, that will be equal to X squared. And all we have to do is take the square root of both sides to get to our X, which is 1.3 times 10 to the minus third molar. Up here we made the designation that X is going to be equal to our concentration of hydronium. So we know what X is, so we know what our concentration of hydronium is. Then all we have to do is plug it into the pH expression. pH is equal to the negative log of the concentration of hydronium. Well, we just found that. Plug that in. Our pH is 2.89.